you don't have to practice a lot this topic. Once you will be done with your class 11 exam, then you have to sit with these topics. And even though it will, sometime it will seems like quite confusing and all, then also just write everything in one place. You will be able to understand it. So we are about to discuss So whenever we are dividing in groups, let's say the question is like this: division in groups. We will be getting, can you see my screen?
Yes, ma'am.
We will be coming to the formula part, but let's see the question, how the question will be there. Here we are talking about groups of unequal sizes. When the group are of unequal sizes, then how we will be using the concept. So suppose the question is number of ways of dividing 10 people into groups of 6 and 4. So if we are going to divide 10 people in group of like 6 people at first and then 4 people. So we can do it like this. You know that whenever we are having 10 people and we have to divide it in group of 6 and 4, you just with the help of your previous concept only, you can say from 10 we are making a group of 6 at first, and then like after that we are taking the remaining 4 in a group of 4. Yes or no? This much you will be able to
Yes,
write with the help of the previous concept which you have learned, right?
yes, ma'am.
Since we are talking about the selecting people, obviously we will be taking the combination. And you know, from 10 at first we are taking 6, and after that we are taking 4 more from the remaining 4, right? And if you we will
Yes,
simplify
ma'am.
it, it will be 10 factorial by 10 minus 6 factorial into 6 factorial. 4c4 will be 4 factorial divided by 4 minus 40 into 4 factorial. So basically it became 1. Can you see? It became 1. and this became 10 factorial by 4 factorial into 6 factorial. This is this and this is this. Is it clear, Lina?
Yes, ma'am.
So basically, I am saying yes, we will be able to do it with the help of the concept. But here we can do it directly when we are dividing number of people in group of unequal size. So you can say 10 people in the group of 6 and 4. So directly, that is the conceptual method. This is the conceptual approach, and direct approach says that we can do it directly by taking 10 factorial by 6 and 4. This 6 and this 4 directly we will be taking, then also we will be getting the answer. Can you see both the things are exactly same?
Yes, ma'am.
So whatever seems convenient to you, you can use that way. Here the direct approach says this way also you will be able to do. Okay, when you are dividing in unequal sizes of groups. Now here the formula says that whenever we are having m plus n people total, and if we are dividing them in m and n different sizes of group, then directly we can find it as m plus n factorial divided by m factorial n factorial. This is what the formula says, and this is what we have applied while applying the direct approach. Can you see?
Yes, ma'am.
Similarly, if we are having m plus n plus p, the total number of people are whatever, let's say, and if we are dividing them in a group of m and p, then the formula says directly you will be able to find the possible selection by m plus n plus p total divided by m factorial n factorial p factorial when we are having group of unequal sizes. Okay, is it clear, Lina?
Yes, ma'am.
Similarly, if one of the questions says number of ways of dividing 10 people into group of 5, 3, 2. As you can see, all the group are of different size. The concept says that from 10 we will be taking 5 at first. Then remaining 5 we will be taking 3 after that. Then remaining 2 we will be taking 2 and we are done with our work. That's what the concept says. And direct formula says that we are having 10, we are dividing 5, 3, 2. So we can take directly as 10 factorial by 5 factorial, 3 factorial, 2 factorial. And by doing any of the method, we will get the same answer. Is it okay?
Yes, ma'am.
When we are having group of equal sizes, then what can be done? Now, groups of equal sizes. Here we were having group of unequal sizes, and that's why directly we have applied the formula also. When the group are of equal sizes, then what can be done? So for that, let's take one question which says number of ways of dividing 4 people into group of 2 and 2. Okay, so the method, conceptual method says, okay, 4 people are there, so from 4 we will be taking 2 at first, and then we will be taking 2 after that. But since both the group are of same size, whenever in permutation, while doing the permutation, when we have seen whenever same, suppose we are having a let's say, suppose we are having a word where the word is, let's say, let's take your name only. So is it Lenah, right?
Yes, ma'am.
So if I'll be arranging your name, so we will be taking 2 factorial in the denominator because 2 are there. Yes or no?
Yes, ma'am.
Similarly, here also, since both the group are of same size, we will be taking 2 factorial in the denominator. Okay. So
Okay,
this
ma'am.
is the conceptual approach. Just like the permutation, we need to take, if same objects are there, we need to divide that by 2 factorial. Just like this is the conceptual method, which says we can do like this. And direct method says that 4 people are there and we are dividing them in form of 2 and 2. So we will be writing the formula 4 factorial by 2 factorial into 2 factorial and again 2 factorial. From where this 2 came out, this is nothing but how many times a certain thing is repeating itself. If it is repeating itself 2 times, we will be writing 2 factorial, just like your name. E is 2 times, we are dividing by 2 factorial. If E will be 3 times, we will be dividing by 3 factorial. Right, Lena?
Yes, ma'am.
Similarly, uh, like by that way, by the conceptual way or by the direct method, you will be able to get the answer. The same answer you will be getting by doing any process, by applying any method. Okay. Here you have to be careful since the size of the group is same. So you have to check how many groups are there. How many groups are there which are of same size. To clear it, let me give one example. So let's say the next question says number of ways of dividing 6 people into group of 2, 2 and 2. So if we will be dividing 6 people in group of 2, 2, 2, direct approach says 6 factorial by 2 factorial into 2 factorial into 2 factorial into 3 factorial. Why 3 factorial? Because 3 such groups are there which are of same size. Getting it?
Yes, ma'am.
So this is the direct approach or conceptual approach. If you will be applying, you will end up getting the same result. But there you have to take from 6, you have to take 2 at first. Then from the remaining 4, you have to take off 2 after that. Then from the remaining 2, you have to take 2. And since 3 group are having same size, you have to divide everything by 3 factorial. So by this method or that method, you will be getting the same answer. Got it?
Yes, ma'am.
Now, suppose we are having groups of mixed sizes. If sizes are mixed, like few are same, few are not same, just like the concept of permutations, then what we will be doing? So for that, same way we will be solving it just the way we used to do for permutations. So here it says number of ways of dividing 12 people into two groups of size 3 and 3 groups of size 2. So if you will read the question carefully, you will be able to understand that 12 people are there and we are dividing them into two groups. Two groups of size 3. Two groups of size 3 3. Are you getting it? Two groups of size 3
Yes, ma'am.
and then three group of size 2. So 1, 2, 3 groups are there of size 2 2. If you will be applying the direct formula, so the formula says 12 factorial over 3 factorial, then 3 factorial, then 2 factorial, then 2 factorial, then 2 factorial. But how many groups are there which are having the same like size? So two groups are there which are having same size, so 2 factorial. Now again, how many groups other group is there which are of same size? So here three groups are there which are of same size, so 3 factorial. Is it clearly now?
Yes, ma'am.
This is how we will be solving the mixed group problem. Okay, so these are the concepts which are related to division into group. Now let me take the next concept. Now we are going to take multinomials theorems. So what does this formula says? Previous one is crystal clear, Lina, right?
Yes, ma'am.
Let's move ahead. So the theorem says that in this theorem, you don't have to just go through the theorem for now. We will be taking the example, we will be understanding the meaning of that, and then we will get back to this theorem. But before, just since we are just starting, let me write the theorem. But now we will not be discussing the theorem. So here the theorem says in this theorem, we try to write all possible outcomes in powers of random variable x, and then calculate the coefficient of required power. Okay, so we will be coming to this theorem, but let's write few things. So we are having binomial after this chapter, right?
Yes, ma'am.
So yeah, after this chapter we will be discussing binomial theorem. There we will discuss how to expand when we are having binomial form. That we will be discussing in detail over there. Here just for knowledge, I'm taking one formula and you just keep it in your, just write it in your notebook for a while. In binomial theorem chapter, we will be discussing the same concept in detail. So the concept is, which is very important for solving this multinomial. So the concept says that the coefficient of x to the power r in the expansion of 1 minus x to the power minus n is n plus r minus 1 c r. So basically this came from the binomial expression. Okay, whenever we will be expanding 1 minus x to the power minus n, we will be getting a lot of different terms, and just by observing those terms, we can say that the coefficient of r in the expansion of this one will be this one. Okay, once we'll be starting binomial theorem, I'll be taking the same concept again. Okay, for now, just let's keep it as it is, as a rule. Okay, is it okay, Lina?
Yes, ma'am.
So this rule says that the coefficient of x to the power r in this expansion will be like this, that n plus r minus 1 cr. Okay, let's take one question. Here the question says find the number of ways of distributing 10 mangoes among 3 students without any restriction. Whatever you have learned the concept of permutation and combinations, that was for distinct object, that was for like each and every object was distinct over there. That time we were taking directly 10c3 10p3 like that. Okay, but here we are talking about all the mangoes are same, and there is no restriction. When we are distributing the mango, there is no restriction. If you are having 3 students, if you are having 3 students, then for the first student, like the first student, you can give no mango, you can give one mango, you can give two mango, you can give three mango, like that you can give 10 mangoes. So either if you want, you can skip the first student and you can start distributing in between the rest of the two, because there is no restriction. It depends on you how you want to distribute this 10 mangoes which are all identical. Okay, similarly for the second student, if you want, you can skip the second student. That means you can give no mango to the second student, or you can give one mango, or you can give two mango, or you can give like three, four, five, six, all the mango you can give to the second student only, and you are done with the distribution. So this type of question we cannot apply directly the concept of permutation or combination, the formulas which we have learned NPR and CR, that we cannot apply it over here since all the mangoes are identical and since there is no restriction. Okay, is
Okay,
it
ma'am.
okay? Are you there?
Yes, ma'am.
So here we are going to use a certain process, certain formula, which says that first let me write what will be the possible cases. So I can say for the first student we can give no mango, we can give one mango, we can give two mango, we can give three mango, we can give four mango, then five, six, seven, 8, whatever mango we are giving, that we are writing in the form of exponents. Okay, then 9 or 10. These are the total possibility for the first student. Similarly, just like this we will be having the possibility of the second student, and just like this we will be having the possibility for the third student. Agree?
Yes, ma'am.
So here we are saying that total possibilities are. Now let's get back to the theorem. So the theorem says, in this theorem we try to write all possible outcome in power of random variable x. Can you see I have written as a all the possible outcome I have written in the form of random variable x power 0 mango, 1 mango, 2 mango, 3 mango, 4 mango. Like that only I have written it down, right?
Yes, ma'am.
And then what we have to do, then we have to calculate the coefficient of required power. Then we will be calculating the coefficient of required power, that we will be understanding, we will be discussing in a bit. Okay, let's write it first. All the three possibilities are x to the power 0 or x to the power 1 or means addition, right Lena?
Yes, ma'am.
Then 2, then or x to the power 3 or x to the power 4 or x to the power 5 or x to the power 6 or x to the power 7 or 8 or 9 or 10. Similarly, we will be taking the same thing again for the other student, that is 0, 1, let me write it quickly, 2. And we also need to write the possible cases for the third student. So these are all the possibilities which we have written, and in concise manner, since we are just multiplying the same thing again and again for 3 students, can I write it as x to the power 0 plus x to the power 1 plus x to the power 2? Power 3, can I write Lena?
Yes, ma'am.
Uh, now can you see it is in geometric progression? Do you know about geometric progression? Arithmetic progression you have done in previous class, uh, in
Yes,
class
ma'am.
10. And geometric progression, do you know about that?
No, ma'am.
So geometric progression looks like this one. 1, let's say we are having 2, then 4, then 8, 16, 32. So basically just like arithmetic progression, there is a geometric progression where we are having, in arithmetic progression it was common difference. Here we are having common ratio. If you will find the ratio between 4 and 2, you will be getting 2. If you will be finding the ratio between 8 by 4, you will be getting 2. If you will be finding the ratio between 16 by 8, you will be getting 2. So in arithmetic progression, we used to have the common difference. The difference between the number were same. But here we are having the common ratio. That means the second term by first term, that ratio or any two consecutive terms ratio will always be same, and such sequence is called geometric sequence. Okay. And in arithmetic sequence in class 10, if you will recall, there was a formula for sum of n terms was n by 2, 2a plus n minus 1 into d. Have you seen this formula for finding the sum of n terms in
Yes,
arithmetic
ma'am.
progression? Similarly, in geometric progression, for finding the sum of n terms, we are having a rule. Let me write it. For geometric sequence, we are having S n is equals to here like two cases can be there where your common ratio is less than 1 or it is greater than 1. So if it is less than 1, then the formula is 1 minus r to the power n, like a 1 minus r to the power n by 1 minus r. This is the formula we are having when r is less than 1. Okay, and when r is greater than 1, then the same formula we write r term at first, and then we write like the same thing, we write a r to the power n minus 1 by r minus 1. So either this formula we use or this formula we use. We will be discussing it in detail in sequence and series chapter. Okay. For now,
Okay,
you
ma'am.
just keep it in mind that this rectangular box is the formula, and it is just like the arithmetic sequence. We are having a geometric sequence. Arithmetic sequence, we used to have the common differences same. Here we will be having the common ratio same. Ratio, as the name says, common ratio same. Okay, and for that we are having sum of n term. This is the formula. Okay. Now let's get back to our question. In our question, if you will look at it closely, the first term is x to the power 0, that means 1. The second term is x. After that we are having x square. After that we are having x cube. And if you will be checking that common ratio will be x by 1, yes or no? Or if you will be doing
Yes, ma'am.
x square by x, it will be again x by 1, right?
Yes,
So
ma'am.
metric sequence, because the common ratio is same, and we will be using this formula. Let's use this formula. Since sum is there, so sum of 10 terms we will be finding as 10 is equals to a. The first term is x to the power 0, that means 1. A 1 minus common ratio is x. Okay, 1 minus x to the power n means 10, divided by 1 minus x. Is it clear, Lina? I have used this
Yes,
one.
ma'am.
Okay, just a moment. One thing we have to consider here. If we are having x to the power 0, then 1, then 2, then 3, then 4, then 5, till 10, how many total terms are there? 10 or 11? If you will start counting from 0 till 10, how many total terms are there? 10 or 11?
11.
11 term. So rather than writing as 10, we will be writing as 11 here because we are finding the sum of 11 terms. Yes or no?
Yes, ma'am.
And instead of writing this power as a 10, we must write power as a 11 because we are finding the sum of 11 terms from 0 till 10. Okay.
Okay, ma'am.
Now now as we can see, this one is, can you say this one is having power 3?
Yes, ma'am.
Whatever formula we have applied, that formula is okay for one of the geometric sequence, but we are having power 3 over here, 3 geometric sequences. That's why the formula, in formula also we are giving power 3. Is it okay? The sum of n term formula is this one, and since that is having power 3, I have copy pasted power 3. Can you see?
Yes, ma'am.
Is it clear so far?
Yes, ma'am.
Now let's simplify it. So we will be having 1 minus x to the power 11, that's power 3, into 1 minus x to the power negative power 3. Can I write? When I am taking this denominator's term, in the numerator. If we will distribute the power to numerator and denominator, numerator will take power 3, denominator will take power 3. Just like this one, a by b to the power 3 will be a to the power 3 by b to the power 3. This b to the power 3, if you will bring it in the numerator, it will be a to the power 3 into b to the power minus 3. Yes or no?
Yes, ma'am.
So let's write it. This is having minus 3. Now what we need to find, this one we can expand it according to the formula of a minus b whole cube, right?
Yes, ma'am.
What is the formula? What is the formula, Lena? A cube
A cube minus B cube plus 3AB
plus 3ab or minus 3ab.
minus 3AB.
In bracket a minus b, right?
Yes, ma'am.
And let's write the other one as it is. Eleven plus 11, can I say it's 22? Can I?
Yes, ma'am.
Is it clear so far?
Yes, ma'am.
Here we have to find the coefficient of x to the power 10. Let's get back to the theorem. The theorem says, in this theorem we try to write all possible outcome in powers of random variable. We have written all possible outcome. We have written that, and then we found that okay, it looks like geometric progression. So we can apply the formula of sum of the geometric progression. We have applied the formula. And then it says that the theorem says then calculate the coefficient of required power. Okay. So we will calculate the coefficient of x to the power 10 over here, since we are having 10 mangoes. Okay. We are having 10 mangoes and 3 student we are dividing. That power 3 already we have taken in consideration, right?
Yes, ma'am.
So here now our purpose is, our motto is to find x to the power 10. Okay. So we will be finding from here, we will be finding coefficient of x to the power 10. Since x to the power 33 is too big, so neglect that. Okay, x to the power 11 is too big, so we need to neglect that, because we want to find the coefficient of x to the power 10 when we will be doing the multiplication of curly bracket with that term. So we want to take it out, the coefficient of x to the power 10 only. So 33 is not there, like we can't take 33, right? X to the power 33, whatever you will multiply with that, it will not give the coefficient of x to the power 10, right?
Yes, ma'am.
X to the power 11 is already, the power is big. Whatever you will do the multiplication, it will not give you x to the power 10. Similarly, 3x to the power 22 is already such a huge power is there. So definitely it will not give us the coefficient of x to the power 10. So why I'm just cancelling this 3? Because I want to neglect this 3. Okay. So now we are having only 1 in the curly bracket, and we are having 1 minus x to the power minus 3 over here. If we will be doing the multiplication of this two, we will be getting 1 minus x to the power minus 3. And in the very beginning, I told you to keep in mind one formula, that this important one, that coefficient of x to the power r in the expansion of this type of term is this one. Can you see? So
Yes, ma'am.
there we are having 1 minus x to the power minus 3, right? It will
Yes,
be
ma'am.
n plus, and we have to find coefficient of x to the power 10. So we can see r is 10, n is 3, right, Lena?
Yes, ma'am.
Let's apply the formula which says n plus r. So 3 plus 10 minus 1 c r, that means 10. Is it okay?
Yes, ma'am.
So we will be having 13 minus 1, that is 12 C10, right?
Yes, ma'am.
Let's take this. This thing we need to do it there. But since here we are having the formula, we are able to apply it. So 12 C10 we will be having over here as coefficient of, that is our final answer. We just have to do the calculation now. The combination calculation, that is 12 factorial by 12 minus 10, that is 2 factorial, 10 factorial, like that. Okay,
Yes, ma'am.
so just a moment. So let's summarize the whole concept. Okay, so what exactly the concept says: in this theorem we try to write all possible outcome. First we have written all possible outcome, that means 10 mango, 3 people, and the possibility for the first one is 0 mango, 1 mango, 2 mango, 3 mango, 4 mango, 5 mango, 10, like that, 10 mango. Similarly for the other one, similarly for the other one. So we have written that in the power of x, like this. And since we are saying for each and every member the same possibility is coming, so why not to write it as a power 3? Okay, once we have written it as power 3, now we can see that it looks like geometric progression. So let's apply the formula of geometric progression to find the sum. But power 3 was there, so that will just get copy pasted as it is in each and every step. All right. Now after that, we have just expanded it. After doing the simplification, we have to find the coefficient of x to the power 10 over here. Okay, since 10 mangoes were there. So for finding the coefficient of x to the power 10, we have just expanded it, whatever the term was there which was having the higher power, we have neglected that, and then we have applied the formula to find the coefficient of x to the power 10. The binomial expansions formula we have used to directly find the coefficient of x to the power 10. Is it clear, Lina?
Yes, ma'am.
Actually, why we are finding one thing you can understand one more step over here. That is, we are having three boxes or three persons. So we can give 0 mango to the first one mango to the second one, and the remaining mango to the third one, right?
Yes, ma'am.
This is one of the possibility. So here the power will be x to the power 0 into x to the power 1 into x to the power 9, right? That means x to the power 10 only, right, Lina?
Yes, ma'am.
Or the other possibility can be we are giving one mango to the first person, we are giving one mango to the second person, and we are giving the remaining 8 mango to the third person. So the first one became x to the power 1, next one became x to the power 1, and next one became x to the power 8. That's why we are finding at last the coefficient of x to the power 10, which will give us all the possible outcome. Okay.
Okay, ma'am.
So these are the process whenever we have to find the, like, use the concept of multinomial. Still, you need to solve few questions on this concept related to this concept. But for now, you can note down the concept. You can keep it aside. Okay. I'm moving to the next concept. Do you know this formula? Inclusion. I'm just giving a different name to this formula. Once I'm going to write the formula, you check it whether you know this formula or not. Or not or. Principle. Have you seen this formula?
Yes, ma'am.
Union intersection formula, which you have done in the set chapter, right? So
Yes,
here
ma'am.
we are going to use this formula, and we are saying this is called inclusion exclusion principle. Why inclusion exclusion? Because you can see when we are taking number of element in A, we are taking everything in A. Then we are taking everything in B, and then we are removing, excluding. First we are including, and then we are excluding, right?
Yes, ma'am.
Similarly, for three sets, the same formula is an A union B union C is first we used to take including everything, number of element in A, number of element in B, number of element in C. Let's exclude, like include that. A, B, we have included everything. Now we need to exclude. So let's exclude the number of element in A intersection B at first, then number of element in B intersection C, then number of element in C intersection A. We are excluding 2, 2, 2. Okay. Now at last, since we are talking about A union B union C, that means we have to take like all the sets, the union of all the sets. That means we need to include now number of element in A intersection B intersection C. This is the formula, the same formula for three sets. Are you getting?
Yes, ma'am.
On the basis of this formula, we are going to solve few questions. Let's do that. The question says, find the number of positive integer from 1 to 100 which are divisible by at least 3 or 5. So which are divisible by at least 3 or 5 or both. That is the meaning of at least, right? That minimum this one or everything, right?
Yes, ma'am.
So let's say our set A is the number of element divisible by 3. B is divisible by 5 and A intersection B means divisible by both. How we will be finding? We are having a number from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 till 100. So you can just make the arithmetic progression and you can go ahead and you can find the number of terms which you used to do in the previous class in class 10 in arithmetic progression chapter. Whenever you are having 1 to 100, what you used to take, if you have to check divisible by 3, then the first term is 3, second term is 6, third term is 9, like that. Before 100, we are having 99, which is divisible by 3, right?
Yes, ma'am.
Nth term or the last term formula says L is equals to A plus N minus 1 into D. There we used to apply the formula, here 99, here A, here, and we don't know how many terms are there, and D is 3. So we used to get N value over there. That is N is 99, right?
Yes, ma'am.
Similarly, we can find number divisible by 5. We can find number divisible by both. There is a shortcut for that. What is the shortcut? Just go and divide the larger number, the maximum number 100 by 3. So if you will divide 100 by 3, you will see 3 is going 3 times 9 and then again 3 times 9. So 33 times completely it is dividing 100. That means 3 into 33 it is completely dividing and 99 we will be getting from there. This is the shortcut. If you want to go by AP you can go, and this is the shortcut which you can get directly here as a 99. Are you getting it?
Yes, ma'am.
If we have to check by 5 we will be dividing 100 by 5 and the number of time it will divide completely, that we have to figure it out. So I can see it is dividing completely 20 times and no remainder is there. So 20 into 5 is 100. So total number, this quotient into this we are doing at last to get the total number of terms. Okay, so 100 terms are there. Yeah, is it 100? Just a moment now. Are we doing any mistake? 3n. Okay, yeah, we are doing mistake. So when applying the short trick here we will be, this answer is wrong. Can you see n value will not be 99 over here? Here it will be 99 is equals to 3 plus 3n minus 3. So n value will be 99 by 3. That means 33. Can you see?
Yes, ma'am.
Here also we don't have to multiply after that. The number of time it is dividing the larger number properly, perfectly, without any remainder, that only we will be taking. We don't have to take the decimal value. So 3 is dividing 100 33 times fully. And whatever is remainder, let's keep it aside. So 33 will be the total number of terms. Similarly, for the next one, when you will divide 100 by 5, you will be getting 20. 5 20 times dividing 100. Okay, whatever is remainder here, the remainder is 0, well and good. Even if the remainder is 1 2 3 4, we will be keeping it aside and we will be just taking the quotient part. So here the quotient is 20. Is it clear, Lina?
Yes, ma'am.
Similarly, if we will be checking with 15, so how many times 15 will divide 100 completely? So 15, 5 times 75, 15 6 times 90, 15 7 times 105. So 6 times 90, right? So we will be having 6 over here. Getting?
Yes, ma'am.
Either we can apply the short trick or we can go ahead and we can apply the arithmetic progression rule. So we got an A, we got an B, we got an C, an A intersection B. What we have to find? That find the number of possible integer from 1 to 100 which are divisible by at least this or this or both, right? So we have to find an A
Yes, ma'am.
union B over here. That is the meaning of at least one or two. Either the A union B means element from A, element from B, or element from both of them, right?
Yes, ma'am.
So we can apply the formula now, Na plus Nb minus N A intersection B. And easily we will be getting the number, the possible number which are like divisible by 3 or 5 or both. Okay? Is it clear to you?
Yes, ma'am.
Similarly, when we will be having three cases, then we will be using the same way we have to go ahead. Okay? Now let's do the other concept. Yeah, just a second. Now we will be seeing the concept related to sum of numbers. Let's see. Here what the formula says. For non-zero distinct digits, the formula is n minus 1 factorial into sum of digits into 1 plus 10 plus 100, like this. Let's see what exactly how the question will be framed and how we can use the formula. So the question will be like this. Question: find the sum of all 4 digits numbers that can be formed using the digits 1, 2, 3, 4. Okay, so the question will be like this, that find the sum of all 4 digits number that can be formed using the digit this one. Okay, so for this type of question, the formula says whenever we are having non-zero distinct digit, then this formula can be applied. What the formula says, that n minus 1 factorial. So we have to make 4 digit number. Total number of digit 4. So what we will be using, 4 minus 1 factorial into sum of the digit 1 plus 2 plus 3 plus 4 into 1 plus 10 plus 100. What is this? This is the number of places. We need 4 digit 1, 2, 3, 4. So ones, tens, 100, 1000. Are you getting it? So we will be taking 1
Yes.
plus 10 plus 100 plus 1000. If it will be 3 digit number, by giving the 3 distinct digit, then we will be taking till 100. If it will be 2 digit number, then we will be taking till 10 only. Okay. So we will be having 3 factorial over here. 4, 5, 6, 7, 8, 9, 10. 10 over here, and here 10 plus 100 plus 1000. If we will be adding all of them, you can see here we are getting 1, 1, 1, 1. Can you see?
Yes, ma'am.
And this will give us 3 factorial, means 3 into 2, 6 into 10 into 1, 1, 1, 1. That means 60, or we can say 6, 6, 6, 6 into 10. This one is the answer. So what was the question? Find the sum of all 4 digit number. We have to find the sum of all 4 digit number that can be formed using this digit. And this one is the answer. Are you getting it?
Yes, ma'am.
Now there is a question related to de-arrangement. Arrangement question we have done with the help of concept of permutations or space filling. The de-arrangement is what? We will be de-arranging the given condition. Like suppose 3 places are there. Suppose 3 suppose 3 houses are there. The first house is of A, second is B's house, third is C's house. So we have to do such a de-arrangement so that nobody will be able to go to their home. So A can go to B's place, A will go to C's place, but will not go to his own home. Okay. Similarly, B can go to any other person's house, but not his own house. Okay. Similarly, C will go to any other places except his own house. That way we have to do the de-arrangement over here. The way we used to do space filling, this is the completely reverse of that. Okay. So this is the case of de-arrangement. If we will be having such a de-arrangement, then how we will be solving the question. So for now, we will be using the concept. It is the number of way of arranging an objects in n places such that no object goes to its designated place. Are you understanding the meaning of the sentence which I was telling you? Okay. Such a arrangement we will do so that nobody will able to go to his designated place. So for that we are having a formula dn is equals to n factorial 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial, like this. Plus minus, the alternate sign will keep on going. Minus 1 to the power n, 1 by n factorial. Okay, let's see the question related to it. So question says find the number of ways of placing 5 letters in 5 envelopes such that no letter goes in correct place. Just by reading the question you will be able to understand, okay, it's from the dearrangement case. Are you able to understand just by reading the question?
Yes, ma'am.
Now let's use the formula. The formula says the formula is n factorial. So how many? Let's see what was n. N object, n places. Okay. So 5 object, 5 places, 5 letters, 5 envelope. So it will be 5 factorial, right? 1 minus 1 by 1 factorial plus 1 by 2 factorial. This way we have to go till which number? 5 object, 5 5 letters, 5 envelope. So we have to go till 5. Okay. Minus 1 by 3 factorial plus 1 by 4 factorial minus 1 by 5 factorial. Is it clearly now? This will give the possible way
Yes,
of
ma'am.
rearranging this 5 letter in 5 envelope. Okay. Similarly, whatever be the question, this way only you will be able to do that. Now the last concept, today's last concept, that is exponent of prime, which says that let P be a prime number and be a positive integer. Then exponent of P is n factorial and is denoted by E P n factorial and is given by EPN. Let me write the formula. N by P plus n by P square plus, if you are thinking that why I'm writing the this rectangular bracket like this, then this is the n by P cube. This way, n by P to the power n. This is the greatest integer function. Okay. Now, how the question will be there? Let's see the question. The question will be like this. Find the exponent of 2 in 10 factorial. We have to find the exponent of 2 in 10 factorial. So if you understand the meaning of factorial, you know 10 factorial means 10 into 9 into 8 into 7 into 6, 5, 4, 3, 2, 1, right?
Yes, ma'am.
And here we have to find the exponent of 2. Obviously, you can see we will be getting 2 from this 8, we will be getting 2 from 6, we will be getting 2 from this 10 also, 4 also, 2 also. So manually, if we will do 10 factorial is fine, but it will be 100 factorial, 200 factorial, then it will take some time. Yes or no?
Yes, ma'am.
So to find the exponent of 2, directly we can use the formula. What the formula says, if p be a prime number and n be a positive integer, then the exponent of p, exponent of 2 in n factorial, where 2 is a prime number you can see, and we have to find exponent of 2. And n is a positive integer, obviously 10 is a positive integer. Then the formula says that e to 10 factorial or 10 will be n by p, that means 10 by 2 plus 10 by 2 square plus 10 by 2 cube. Till what time we will be taking the denominator? Till the time where the denominator will be able to divide the numerator. So 10 by 2, 2 can divide 10. 10 by 2 square, 4 can also divide 10. Right, Lena?
Yes, ma'am.
10 by 2 cube means 8. 10 by 8, yes, it is divisible. Now, if I am going to write the next term as a 10 by 2 to the power 4, that means 10 by 16. Can 16 divide 10 without decimal and anything? 10 by 16 is possible, yes or no?
No,
Can we
ma'am.
divide 10 by a number 16 without decimal?
No, ma'am.
So we will be taking the denominator, or we will be taking the number of 10, number of terms accordingly, so that it can divide by any positive integer. Decimal number is perfect, but that decimal should not be 0 point something. Okay, so let's do the division and let's check what are we getting. So we are having, the formula says it is 10 by 2, it is 10 by 2 square, and it is 10 by 2 cube. Greatest integer function says to 5 times 10, we have to take only the integral value. 10 by 4, if you will divide 10 by 4, 4 2 times 8. So you just have to take the integral value, because you know after that there will be decimal. We don't have to take that. Greatest integer function means that only. Right, Lena?
Yes.
And 10 by 8 means 8 is going to divide 10 how many times? 8 1 times 8. And after that 1 point something will come. Point we don't have to take. The total, the integral value we just have to take. 5 6 7 1 8. So the power of 2 will be 8 over. Getting?
Yes, ma'am.
So let me check, is anything left or what? No. We are done with today's concept. And permutations and combination, today we are wrapping it up. So these are the concepts. It will be saved over here if you have noted it down. Well and good. If you have not noted it down, we can share it with you, and you can keep these notes in one place. Okay? Okay, Lena. Do you
Yes,
want
ma'am.
to ask anything from here?
No, ma'am.
So these are the concept. Now, as I said to you, first prepare fully the class 11 concept and then come to this concept. These concepts are very important. Once you will go in class 12, then nobody will